So I'm Vlad Vinogradsky, and I have a pleasure and fun of speaking on behalf of our team about API management and API economy here today with you. And I appreciate you all for coming. We've got here in front row some of the members of the team. Evgeny. Evgeny, I don't know if you guys know, but API management came out of an acquisition that Microsoft made a couple of years back. Actually, maybe less than that, year and a half, of a small startup called Epiphany. And Evgeny was the founder and the CEO of that startup. So he's essentially the reason we are here in this room today. So here's Evgeny. And there's also Mark. Mark is our marketing manager, helps us with promoting the service and getting you all guys excited about it. So let's go forward with this session. So this is just a quick, customary few questions for me to better understand who you guys are. Can you show a hand if you are an IT pro, if you're managing systems? Okay, probably maybe a quarter. A developer? Wow, I see, okay. So the session was classified as enterprise developer, so I guess they didn't mess up that one. And who is neither? Like, maybe project manager, program manager. Okay, a few, excellent. So how many of you guys are actively involved with APIs? The building or managing or exposing them? Excellent, you're in the right room then. And then who heard, or better even, is a user of API management? Quite a few. Excellent, excellent. Thank you very much. We appreciate your support, guys. All right, so this is a deep dive 300-level session with a fluffy title, right? So that was our mistake. But we're gonna talk a little bit about API economy and sort of motivate the need for APIs and API management. And this is really not a sort of exhaustive survey, but rather just to give you an idea and some examples of how APIs might be useful and what business models people take advantage of to create value for their organizations. And then we'll talk more about the product, and I hope that will be the longest part, the bulk of the session. And I actually will do a lot of demos today, and I hope you'll like them. I will be demoing some of this stuff first time here in this room, and some of the features that I'm going to be showing you I haven't even shipped. So you'll get to see a sneak peek of some very cool stuff we're working on. And as always, and our customers know that pretty well by now, I hope, that we're extremely sort of customer focused, always looking for feedback and really eager to have conversation and understand your needs and meet them better. So with that said, let's go forward with this session. So, APIs are essentially mainstream these days, right? So they were sort of obscure technical subject. Now everybody's talking about APIs. Even people who are not in technical fields know what APIs are, right? There is, obviously, everybody has an opinion why, APIs are so important these days. Sort of my kind of quick sketch of how I think about it is that, somewhere in the late 1990s, early 2000s, cloud platforms and software as a service applications started showing up. Obviously, a bunch of IT on premises. There are these cloud systems you need to integrate. HTTP-based APIs were it, right? So those were very successful. First SOAP, quickly replaced by sort of what we call RESTful APIs. So that was going very well, and people were using APIs to manage the system, integrate with them, pull data back, load data into those systems. With some, when the systems started to proliferate, they started, there was, it started to be interesting to integrate those. So that also, sort of made APIs even more useful. And then, of course, mobile, surged, right? And, there's billions of phones sold, and, there's billions of apps and stores and all that. And frankly, I mean, I don't know if there's such statistic, but as far as I'm concerned, any good app you take today on a mobile phone, tablet, or even PC, I think there will be at least several APIs behind it, right? Some of those APIs are used to pull the data and fulfill sort of key function or major function of this API, or core function of that particular application. And then yet others are used to upload telemetry, usage data. Yet others are used to integrate with services like Dropbox and Box and other storage systems or other applications there. So each app essentially is a consumer of multiple APIs. And so at this point, with this kind of bulk of interesting use cases, if you don't have an API, you're not participating in that ecosystem, right? And so having an API today even became mandatory. I think that any startup in a technical field today, right, they're probably API first, or at least they build it with their core product right away, right? It used to be that was sort of an afterthought. But these days, I mean, I think that's what people kind of think about at the very first moments they start doing this. So, and lastly, there's this emergence of API-centric architectures, right? So now, people talking about microservices that API enabled, and you sort of compose them to build applications, and that's an interesting trend. Essentially, is gaining momentum, and you may argue that we saw this before, and we don't know how successful that's going to be. But this is something that makes sense, and hopefully on this sort of on this part of the spiral of technology development, maybe it will actually fire and will become a lot more successful than similar sort of componentization strategies were in the past. Now, speaking of API-centric architectures, I think I pressed the wrong button here. I'd like to make you aware of this talk by a sister team. You probably are aware that Microsoft announced App Service, essentially a platform for APIs and microservices and these API-centric architectures and applications. And one component of that platform are API apps that are essentially is a technology that allows you to build APIs on Azure, quickly, efficiently, connect them to on-premises systems, etc. So this session is happening tomorrow. So if you're interested in that subject, I definitely recommend attending it. It's going to be great. So, obviously APIs are so popular, they should have some value, right? I mean, it's not just a fad. So yeah, I mean, they actually help companies grow. Simple use case, monetizing data and services, right? This is where API sort of becomes the product of the company, or one of the main products of the company. And there is plenty of examples like that. There is all these startups, like Stripe and SendGrid and Mailgun and PayPal and et cetera, who actually, sell access to API, right? And essentially monetize the service that the company provides. Some others expose APIs to become a platform. And, canonical example there would be Salesforce. These guys basically had a very successful CRM system, but very quickly they exposed an API. And now they claim that, over half of their transactions happening over API, right? And it becomes an extension point, and they're used by customers, they're used by partners, and there's, a huge ecosystem around their platform, which makes their product a lot more valuable, a lot more sticky, right? And so that's definitely is a very significant sort of segment of how people derive value from APIs. A lot of companies use APIs internally to innovate faster, essentially creating, because APIs exposing sort of these what we call RESTful APIs or HTTP-based endpoints with good documentation, easy to use. There's plenty of frameworks and tooling around it. Makes it very easy for people to start building apps. And or connect systems together to create something new, right? And that's sort of a great benefit of essentially taking stock and inventory of your APIs in the organization, exposing in a consistent, easy-to-use way, reduces barriers of entry, and sort of fosters innovation. And lastly, there is companies who use APIs to essentially open new channels to new customers. Essentially, if I open an API that's used by my partners who essentially resells my services or products to that partner's customers, I'm reaching some new customers that I have never reached before, and that's a very common case, and again, canonical example for that would be Expedia. They drive billions of dollars of net new revenue through partner network using the API. And so if you look at all of these are not neat buckets. These are just sort of rough segments. And in many cases, it's a lot of those circles get covered in the same organization, right? So it's not sort of mutually exclusive. Usually it's a combination of those. So here are some common scenarios that we see in our customer base. Mobile enablement is one, and in sort of those scenarios again are not crisply defined. They are not exhaustive. There's a lot of overlap. There's a lot of nuances, but these are sort of roughly broad strokes what we see. Mobile enablement is one, right? And there, of course, questions of optimization coming in, questions of authorization and security. Those usually are driven by first-party apps first, and sometimes they sort of developed into partner ecosystem plays where you're starting to open your API for third-party developers so they can go and build their applications on top of your API and sort of work for you essentially, right? It's amazing if you open your API, right, and people build applications or integrations around it. Essentially, they are working for you without you even knowing they exist. I mean, that's an interesting concept. So partner ecosystem, especially for large organizations, you need to present more of a facade, easy to use. There's a question of packaging your APIs and sort of targeting different groups of your partners, maybe tiering them somehow. Obviously, usage limits comes into play here. If you have tiers, they probably have associated usage limits. You really want to have, good feedback and support for your partner ecosystem, et cetera. So that sort of concerns in that bucket. And of course, business agility, as we talked about, this is about, essentially enabling internal use of APIs or sort of migrating, transforming your IT from sort of monolithic systems, monolithic applications to this sort of API-centric architectures. And there, there's normalization of legacy backends, and it may be not a, kind of accurate word here, but what I meant was that, within organizations, people actually try to enforce some kind of standards, right? That APIs look the same, they use certain patterns, they use certain authentication mechanisms. So commonality and irregularity is very important within the organization. So, catalog, single point of discovery is very important, right? And usually with that comes really scale, right? If in partner scenarios you may expose, a handful of APIs, maybe tens of APIs, Organizations as big like Microsoft, has thousands of APIs, right? So that's, that requirement. And of course, when you are sort of using APIs internally, organizational identity plays a big role, right? So you want to kind of have single sign-in and things like that. So this is how we see the playing field today. And some of the examples, like with partner ecosystem, for example, we have this customer Zomni, spelled with X at the front. And these guys basically produce a software as a service platform for retailers, sort of omni-channel retailing, allowing them to load data and assets into that platform and then sort of light up a bunch of experiences in stores and outside on mobile, et cetera. What's interesting with them is the sort of the nuance they bring in, which we're starting to see actually even in other customers, right, which is kind of fun, is that, not only obviously, if it's a platform and you load data and you should be able to get it out, so you have to have an API, and so these guys provide an API for their customers. But they also, since these customers have their own partners, they have to actually enable their customers to run an API program for their own partners. So it becomes kind of multi-tiered system even. So that's a very interesting use case. And for business agility, MSIT is the closest example. By the way, they sort of published, we're obviously collaborating with them. And they recently published a case study on Microsoft IT Showcase, can be found online, where they talk about their challenge, right? The fact that, they now want to be sort of, this mobile first, cloud first strategy that Microsoft have. So they're obviously trying to become sort of a case study for that. And essentially, not only that, but of course provide us with better services. And so they're migrating to this API-centric architecture where they want to sort of break the pattern of building, single-point integrations and monolithic applications and create this API catalog that people can sort of tap into and combine things and create innovative new applications, especially in the company like Microsoft where, half of the company essentially are technical people, developers who actually can build applications. So that would be definitely a very good example of that. And we have other big customers that I cannot speak about who are sort of on the same path, right? So this is very, very common and becoming increasingly common. Here's some fun for us to look at other Microsoft APIs, right? So I don't know, have you heard of Project Oxford? It was announced last week at Build. Anybody? Awesome. Okay, some of you. Very cool project, very interesting APIs, extremely exciting. They even made Hacker News, which was great. Wonderful uptake of those APIs. They basically were built by our technology and research group in collaboration with Bing and other groups at Microsoft. Really interesting APIs, exposing essentially very intelligent services rooted in machine learning. So let me show you, just to give you a teaser of these things. Here's a Project Oxford website, so it's projectoxford.ai. If you get a slide deck, it's there. So what's interesting here, they have 5 APIs right now. So face API, speech, vision, and then this language understanding. Very interesting. So face APIs, like if you go and look, these guys allow you to detect face, detect similarity, identify people. So let's go in. Speech, obviously, it's speech to text, text to speech. And then vision is also quite interesting. It allows you to essentially analyze the image and categorize it, and also do OCR recognition on that, as well as do things like intelligent thumbnailing, right? So that when you create a thumbnail, you create thumbnail of the important part of the image and not just random part. Then language understanding intelligence services allows you to build applications that actually can understand semantics of what people are saying, not just translate it to text, right, but actually understand the semantics and so that you can actually act upon this textual input or audio input. Very cool services. So to showcase Face API, Microsoft built this little tool that went viral and actually pretty engaging. So it allows you to detect, on any image, if there's a human, they basically detect the age of people. So this is stock photo, right? So it kind of, gives you an idea what it does, detects faces, analyzes them, figures out how old they are. So let's try some public figure, right? So we don't embarrass anyone, whose age we know, right? And let's try Elon Musk. So he is actually a public figure, obviously. According to Wikipedia, he is 43 years old. So let's see if we can corroborate that. Let's pick something, some recent image, maybe this one. In the ballpark, pretty close, right? So let's try something new. Let's do this guy. All right, so let's take a good picture of Yoda. That's the network. See, here's the interesting thing, right? One would think he looks like human, but for some reason, this intelligent API actually detects he is not. And it must be the ears, I think. I don't know. So very cool, very interesting set of APIs, easy to use, really well documented. Today, they're available for free on Azure Marketplace. There's ample instructions how to use them. And really, if you think about, there's all sorts of uses you can imagine for these APIs, like this face detection, right? It detects gender, it detects age. I mean, if you are building a dating site, that's an awesome API, right? You can immediately right there on data entry validate the age, right? Are people lying when they're supplying their photos that they're 25? I don't know, right? So that could be cool. Obviously, language understanding is really important if you want to build an application that is controlled by voice as well. And, it's imagine calendar where you can kind of type a free-form phrase and it will create a well-formed event from it, structured event from it. So really cool. So this other one is actually pretty cool service, has been our customer for a while. They essentially, if you are accepting user-generated content, you can actually use this API to detect media that contains child exploitation imagery, right? Which is very, very important problem. And this API, again, is free for qualified organizations, and it's used very broadly by a lot of partners and big and small to sort of participate in this program. So very cool. Now, by the way, the common thing, obviously, between all these APIs that they do use API management in a very nice integrated fashion. So these are basically examples of this partner ecosystem APIs, broad, public ecosystem that Microsoft engages in. And there is obviously, a lot more. So let's go back to the slides. All right. So APIs are very exciting, right? A lot of cool APIs, very interesting. You can get a lot of useful things done with them. In comparison, API management is kind of as exciting as a toothbrush, right? I mean, it's not really, it's something that you use to make something better. It's not really a thing in itself, right? It doesn't have any end user value in itself. I was actually, we discussed it yesterday with Evgeny, and I don't know if it's a good analogy or not. So this, we sort of played with this toothbrush analogy, API hygiene, blah, blah, blah. So interesting. We looked it up in Wikipedia, and again, can't guarantee the accuracy of that. But apparently, toothbrushes have been, known for a while, right? So toothbrush in its current form, where you have handle and purposefully, put in bristles, emerged in about 7th century AD, right? So very long thing. Well, for a while there, it was used very sparingly, obviously, right? And everybody has teeth, at least for a while, right? But very few people actually took good care of them, and suffered as a result, at least some of them. Now, the actual uptake in dental hygiene and toothbrushes started in late 1800s. And since then, obviously, right now, this is sort of given, right? Nobody gives a second thought. There's all sorts of colors and forms and shapes and price points of toothbrushes and other dental products and people using it, and they're very happy with it. And so you can take this analogy and say, API management is sort of like that, right? It allows you to keep your APIs healthy. It keeps your APIs thriving. Protected. And we also see similar kind of uptake, right? There are clever, early adopters who understand that, right, have this insight. They're using it. But this sort of in mass, right, this mass adoption we expect will come very soon. We think, and we see this accelerated understanding that API management is basically essential, right? It's something that if you offer APIs, you have to have, right? And you can get it out of the box using a product like ours, or you build it yourself, or use some open source software. But this is something that is essential, right? And I think this sort of wasn't obvious, even 2-3 years ago. I think it's getting more obvious now for a lot of people. And I think, but then I think that if you look five years down the road, we won't even have to have a session on API management, really, because it will be basically very common and given and not very interesting topic. It will be always interesting to us because we're involved in building technology, but that's a different story. So anyways, why do you need API management? For all these reasons and more, right? So essentially, if you want to expose some backend and make an API out of it, there's important concept is single front door, right? So it's sort of your choke point, your control point. It's a single URL that you're going to get that people will remember and find your APIs at. There's facades that you can build to either hide functionality of your services, expose just partially, change the way they look, change the formats they produce, change their behavior even, introduce things like caching and transformation and other things that I'll show you. Protection, obviously, misuse, abuse, overuse, right? All these concerns, right, can be mitigated. Defense in depth, right? I'm not saying that you shouldn't be taking care of it on many levels, right? You have to have security that is deep, right? But certainly one layer of it, and very important layer, is API management. Getting APIs in the hands of developers, getting the adoption going, right? Getting the conversation with developers going, allowing them to get to use your APIs in mere seconds after they come to your portal and discover, your API. These are important subjects. This is essentially becoming an entry, sort of barrier, not barrier of entry, but something that is expected, right, when people start starting to get up on the APIs. Obviously, insights, right, very important. Who are your top developers? What products and APIs are most used, et cetera. These things are important, can be used in various ways. Health, response, error codes, all that. Very important things. So all of that comes in a little box with the bar on top, which is called the Azure API Management, right? So it's turnkey cloud service provided as an application for you guys. Everybody who instantiates a tenant gets a private one. You get a predictable, consistent performance. You get a security and privacy boundary around it. Has a bunch of resources. We hide all the complexity and machinery of it. There's lots and lots of moving parts inside that box. There's compute, there's storage, there's cache, there's a bunch of things there. All you see is just nice facade, right? So you don't have to worry about managing those things. We'll take care of it. Significant parts are our publisher portal. This is basically a browser-based UI that allows you to manage your APIs, put them in, edit them, export them, look at the analytics, configure policies, etc. Developer portal, it's a place where developers discover your APIs. This is essentially your API portal. This is where your APIs can be found. This is where documentation is. This is where samples are. This is where the interactive API console is, which they can use to play with the service, get to know it. And then, of course, the proxy, right? That's where facading, protection, collection of statistics, all these things happen, right? And it's always in the middle, always watches the traffic, always enforces all the policies that you set in, right? So that's sort of the service. And with that, I'm going to transition and show you some demos. So let's go to 7. So here I have, I instantiate the API management service. It takes, as I said, it's basically a box filled with a lot of components. Getting it up and running takes 10, 15 minutes, so I pre-built one. This is the one that I usually use. It's just a standard sort of interface that you will see in Azure Management Portal. Shows you a bunch of particular, specifics about the service, where it is, what's the IP address. By the way, IP address is stable, so you can actually use it to create your firewall rules if needed. Scale shows you we have developer standard and premium. Developer is our non-production tier, no SLA attached. Has most of the features of the premium, functional features of the premium. Standard is standard and premium are production. Standard is single region. Premium has ability to go to, you can basically create premium instance and deploy proxies everywhere in the world. We have 15 regions where we are, so you can actually pick where you want it to be and how many units of throughput and you want to have there. And you can go and deploy it in every region up to 10 units. So it's a lot of capacity there. Very important and interesting capability. And then in configuration tab, there are things that you can do. When you create the service, you basically get a subdomain of Azure API.net, as you see here. But you always can create your own custom name, obviously, and most customers do, and you should. And then the other thing that we have here is VPN, right? So you can actually participate in Azure VPN, which can basically allow us to attach to your, and call into your private services residing in the cloud, right? And will become basically a public entry point to those, as well as go on-premise and talk to your backends there over this VPN connection, including things like ExpressRoute. So that's basically what we have here. And if you go and look at dashboard back, we have this manage button, which essentially transitions you into the API management experience. So I'm going to do that. Click that button here. So we'll end in the dashboard. I have one API that comes preloaded with the system. I put, some, I configured some service that pings it so that I can show you, some analytics, some meaningful analytics. But we're going to use some different APIs to actually play with the service. So, as you can see, sort of on the left side, there's all the different sort of components here that you can work with: APIs, products. Products are essentially collections. It's a packaging concept. You can put a number of APIs in the product. You can create, write associated terms of use. You can impose consumption limits. And then you can impose also visibility rules that make those products available and visible only to a certain group of developers, but not the others. So you can get APIs that are targeted at internal, external, or you can tier them: silver, premium, bronze, whatever. And that's what products allow you to do. So it's a packaging concept. Through products, you expose your APIs to the public. Policies are, I'm going to show you extensively what they are. And then, of course, developer portal is where you kind of, this is a full CMS. Developer portal that we provide is basically a full CMS. So you can actually style it, and you can host custom content on it as well. So let's go and import an API. That's probably, something that you're going to do naturally first. So I have a few APIs right here. So I'm going to take this guy, calculator. And as you can see, we support two popular formats for now, Swagger and Waddle. So this one is Swagger. So I'm going to assign a suffix for it. And as you can see, I can also add it to the products right here. So I have two. And the reason between is that starter actually has some throttling applied to it. I think you can make no more than like 3 calls in 5 seconds or something. There's, we're going to look at specific rates, and I'll show you how they're getting imposed. So that should do it. So we imported this API. As you can see, through this import process, we actually got, nicely documented API. There's a name, there's description. We've got operations going here. There's 4 basic arithmetics. If you go into add, you'll see that, there's operations defined as a get over that particular URL template. Things in braces are essentially variable parts of this sort of the parameter values. And you can also enter a bunch of other information about the request. You can add additional parameters here. You can configure responses for operations that provide a body in the request. You can define those. So let's go and take a look at it over here. So this is developer portal. That's default look and feel. But I imported the API automatically. I included it in the products. Those products were already published, right? So now I can see it on my site automatically, right? And I have this documentation that came in this metadata exposed in a nice format. So now you can actually go and learn how to call this thing, right? And moreover, you can actually try it. And so it even gives you the ability to provide default values. And so now if we invoke, we're going to get some response, 100 obviously. So that's sort of, very quickly, you can take an API, load it up, and now I'm calling it through the proxy, right? So there's, not a lot of policies configured at this point. We're just tracking usage. We're applying, throttling limits as imposed by products, but basically that's it, right? So right now it's sort of straight through. So let's try some simple things here. One thing we can do is we can actually modernize this URL a bit, right? We're going to say, you know what, we're going to rewrite it like this. And instead of using query, we're going to use path like this, right? So essentially, now your public endpoint will have A and B passed in the path versus query, but we're going to map it to, what actual backend understands, which is query, right? And so if I save that and go back to this guy right here, so now you see that in the request box, right, you see that now the public URL actually has A and B in path. And if I call, right, it still works, right? It still does the proper transformation and goes to the back end as query parameters. And I can demonstrate it by looking at the trace. right? So if I open the trace here, we're going to see that it basically shows you all the things that are happening in the proxy. So you can see that we're receiving a request, right? And you can see parameters are passed as path parameters. And then we're actually mapping it correctly. Sorry about that. We are mapping it correctly to an operation, right? And then rewrite policy kicks in and rewrites the URL, right? And when this handler guy, right, shows you what actually getting called on the back end, right? That's what the URL we're forwarding this request to, and you can see parameters now reside in the query, right? So it's a very simple case of facading, right, where you sort of change the shape of your API, and you saw that it was very easily done, very easily configurable. Now, in fact, we changed it here, but what really happened? Was we actually, if we look at this operation here, we actually added a policy, right, underneath, right? So this was kind of, it's a nice UX for something that people commonly do, but essentially translate into the policy, right? Policies are these little statements that you can add to on the proxy, which change the shape or behavior of your API. And we have a bunch of built-in policies, and they, some of them do cross-domain, enable sort of cross-domain access to your API. Some changes shape, some add query parameters or delete query parameters, or add headers or delete headers. Others transform from JSON to XML and back. Yet others do caching, etc. So there's a bunch of useful steps here that we allow you to apply literally as little snippets of XML, which drastically change how your API behaves, essentially, right? Now, the other interesting thing is that I'm going to show you some of these advanced policies. And for example, the set body policy allow you now to actually change the body of the request and response to your liking, right? And I'm going to show you how to do that, and this is something that we just released yesterday. So that's sort of a piece of new functionality. As you can see, we also have JOT token validation for protection. We can enforce existence of an authentication header by using check header a policy here. We've got various quotas, for rate limits and just consumption quotas and some others. So a bunch of very useful functionality. Let me show you one more policy here. So if I go to calculator AP, well, in fact, let me go to the product, to the starter product. As you can see, this guy has quota applied to it and rate limits, right? So essentially, if we go back, you will notice that I'm using unlimited subscription to call that API right now. So I can call it at will and not encounter any issues, right? So I can, continue calling it, and it's 200 and everything is awesome, right? Now, if I switch to starter subscription, right, that has actually consumption limits applied, right? So here, at some point, right, I'm going to get throttled back, right? That policy that sits there protects your API from improper use. So the starter is intended for people just to try it several times, right, not to overburden the system, and we take care of it through this policy. And if you are using unlimited, obviously, you can still make calls, right? So that's very interesting. Let me show you something else. So if we go to this API today and look at it here, you'll see that it goes to an API that sits in Azure. It's essentially a website, right? Now, what we did is we actually deployed this same service in a virtual machine with a private network in the cloud, right? Just to show you that VPN works. So essentially, I can actually go and change this now. And you notice that when I showed you configuration of the service, you saw that there's VPN there, has been configured. So here I can actually go and use private address, right? Local, private, non-routable address, because I'm part of that VPN. And if I go back here, right, and make a call, you see it takes a little bit longer because this API probably gets spin up. Succeeded. Let's go look at the trace. Here we go. You see that we matched it now. You see that the backend URL is basically the host is this private host. And when we do the forwarding, we are forwarding to the host, and it still works, right, over VPN. So just with changing URL, I'm going to the different service, still works, private versus public, right? And this service that I'm forwarding to today, right now, in this last example, obviously is not reachable from public internet, right? It's a private API, so it's completely hidden from the outside world. And so you don't have to worry about someone, making an end run around API management and starting to work with your service directly where, no policies are applied, no usage limits are enforced, et cetera. So that's just sort of a brief little tour of sort of this basic functionality that we had. And now let me show you something new that we created recently, some of the things that we added. And so we added one capability, right? So before, very recently, policies were applied unconditionally. So as you noticed, probably you can apply them at different levels. You can apply them to the whole tenant, or to a product, or to API, or to operation, right? And then, of course, if there are multiple policies in different levels, they sort of compose into effective policy for a given operation, because at the end of the day, it's always the operation. The request comes for an operation. So those weren't conditional, right? So what we did recently, we introduced is, first of all, conditional policy that allows you to essentially, execute policies, based on evaluation of certain expressions. Now, those expressions are snippets of C#, could be single line or multi-line. And within those expressions, using C# syntax and basic .NET framework functionality, you can have access to context. And that context essentially has all the information about request and response. It also has different other collections of things that you can sort of add to, like set variables, for example, so that you can pass information throughout the lifetime of the request between one policy to another, right? And so those expressions are extremely powerful because if you start combining them with existing policies and this conditional policy, now you can actually create fairly complex and interesting scenarios of how you want to change or manage functionality of your service. And I'm going to show it right now. I'm going to use as a backend this simple API, offered courtesy of RunScope, an extremely nice company that does sort of API debugging and monitoring tools. And so it essentially is a publicly hosted service, has a bunch of APIs. It's a very nice for testing basic HTTP functionality. There's all the different verbs, and you can get user agent and delayed responses and certain status codes on demand. So a very simple service. So what I'm going to do here, I'm going to go and edit. Let me see here. Let me import this guy again. I'm going to go and drag in the Swagger description of this service. I'm going to give it suffix HTTP bin. This is front door at play, right? The suffix is the name of your API now, right? Because URL is always the same, the host name. That will be the variable part, as you can see here, right? And then I'm going to edit, I don't know, to unlimited, so we don't have to worry about any quotas. So done. It's there. So now if I go to the API portal, you'll see that I've got HTTP bin org. And here are some of the operations that I exposed. And this is simple get. And if you try get, you'll see that essentially what it does, it returns information that I passed in the request, right? So there's basically response contains some query arguments and some headers that have been passed. So it's nice for looking at what's going on here. So let's do some simple things that are enabled by expressions and conditional policies. So first thing we can do is, oops, very sensitive mouse. So first thing we can do here is go to policies. And let's say we want to apply it to this specific get operation. Let's go full screen, add policy. I have a little cheat sheet for speed. So here I can have let me just copy here, and I'll tell you all about it. So here I have two policies that are used in combination with expressions, right? So here I'm setting query parameter, which I call xUserID to actual user ID, and see I'm fishing it out of the context. And then I'm also passing comma-separated list of different other context parameters in a special header, right? So it's a very common thing of forwarding some information to your backend so you can have it reflected in the logs and you can do your own kind of accounting of what happened. Or potentially you might want to do some kind of processing that is dependent on some of that information, right? So how do you sort of send some context back to your backend service? This is how you do it, right, using sort of HTTP means. So now if I go back to this GET operation and send this request, what did I do? Did I apply it to the right one? Yeah, here we go. So you see user ID is 1, and that's sort of admin user. That's who I am, right? That's the right ID there in the query parameters. And then here you've got this comma-separated list of values that I send in the header, right? So now you can sort of, in your service, you can parse it, you can extract that information. So very simple use, but very useful. Next thing we can do here is to say, how do you control cache? So today, if you configure, up to this point, when you configure cache, you had to give TTL, time to live or duration of the cached item, as a sort of constant setting when you configure caching policy. What if you wanted to actually use your cache control header that comes from the backend to use that? So this is how you do it. Let's go and apply that caching policy. And fortunately, what we have here is we have an operation that is called cache, which allows you to actually give give certain amount of duration that will be returned as a cache control header, which we're going to process here. So again, very handy API. So let's go to full screen, apply it to this particular operation. So I'm going to put cache lookup at the top, right? So that's, again, nothing fancy here. It's just standard cache lookup policy. And here's a cache store, which actually has the expressions. Sorry. Let me line up it. So here you see that I'm actually getting value of cache control header, and then I'm using regex to fish out the max age value. And there is a default if there is none, right? And so here I can, let me just make it 60, so we don't have to wait that long. So see how, again, with expression, essentially, I change completely how this policy works, right? So now this information is applied dynamically rather than being a constant. So let's save this guy. And let's go to here and call this operation, right? So you see, I can pass in the amount of delay, not delay, but sort of this max age for the server to return to me. And so that will come as a cache control, max age value, which will be processed by the proxy, extracted and applied when we cache that response. So look what happens here. So if we go and do send and look at the trace, you will see that, first of all, cache lookup was a miss, obviously. This is the first time we applied this policy. Then if we go in the outbound, we're going to see that policy expression processed what came from the back end, right? And from the back end, there's cache control header with max age equal 10, as we asked, right? So this policy expression was executed. The value that it produced was 10, so we found that value. And now we essentially applied it when we stored this item in the cache. And let's go and see it again. So it's 10 seconds. So by this time, it sort of that entry is expired. So let's go and make some calls here. Right? Watch max age. You see in response, max age goes down, down, down. Hoop, right? It's again 10. and it again goes down, right? Because we actually, when it goes down, it means that we're turning from cache, and we're obviously giving the, sort of the abbreviated timeline that is duration that is left, right, for this cached item. And you can see that it all works very nicely. So now, essentially, instead of having a constant time to leave, you can vary it, and you can vary it from the back end, and we're going to just key off of it, right? Very awesome. So let me show you something even more interesting in an authorization aspect. So let's say we've got the need to protect, so our API, let's say, fronts a service which should work on behalf, right? Basically by call by a user with a token, let's say. And we want to control the access to different operations of that API based on the claims within the token, right? So we can say that, there are, and we're going to sort of base it on verbs. So if you want to just call operations that are non-mutating, you just need to have a valid token. We don't care about any special claims. However, if you want to be creating items by using post to put operation, then you have to have a creator claim set to true. If you want to just edit, you have to have editor claim, and then it will allow you to call patch. And that's what we're going to do right now. So it obviously makes sense to apply this at the API level. So this is what I'm going to do. I'm going to go to API level and add a policy. Let's go full screen here. It's kind of a big one. And let me copy it. So if you look at this policy, there are a few things to note here. First, I'm setting variable, right? So that, because I'm using this key, signing key, in a couple places. So instead of sort of putting it in multiple places, I put it in just one, and then reference that variable. So you see this string key, signing key, you see how it's used in a couple of places here. So this is one way you can sort of stash information in the context and pass it along, right? And it leaves from the beginning of the request towards the end when it goes back to the caller. And here, as you can see, we have a conditional choose policy. First, basically checks and says, if it's a patch, we're going to have a claim editor in it. If it's post or put, we have to have creator in it, right? And then, of course, as I said, we use this particular key here. So let me copy. Just save this guy, hopefully. Screwed up somewhere here. Choose. Let me just redo the copy and paste just in case. I'm sure I'm missing something here, so instead of debugging, let me just redo this. So let's go up. Go down. Okay. Yep. All right, so I hope that worked. Something happened with the formatting here, but we'll just roll with it. So, so here's the API, right? So right now, obviously, if I make any call, since I don't have a token in it, right, it should not work, right? So let's go and do get. Let's see, yeah, access denied, right? Oh, subscription key, that's interesting. Let's do it again. Yeah, JOT not present, right? So now our policy, in fact, is enforcing the presence of JOT token, right? And this is get operation. All we need is a valid JOT token. So let's go and have that JOT token. So let me just copy this key. And I'm going to use this little handy tool to generate a token in front of you, right? And this is provided by a company called Auth0. Very nice little tool. So I'm going to say that my secret will be this, and it's base 64 encoded. basically just need to go and do this. Right, so right now, what I have here is I have a token that is very minimal. No, there's no creator claim or editor claim here. So let me just copy this token, go back to my service, and now let me add a header. And I'm going to add authorization header with this jot in it, right? So now, since I'm on get, it actually should succeed, and it does, right? So at this point, jot was validated, we are good to go, right? But we shouldn't be able to call post, for example, right? So if we use the same jot, oopsie, right? Doesn't work, missing claim. So now, since we are using post, let's go and add a claim here saying creator and set it to true, right? And this is new token. And so now if we go, if we go here, copy it, then it works, right? So now we have the right claim, everything is happy. So I'm not going to show you a patch, but it's going to basically work the same way. So again, conditional policy and expressions allow you to create pretty sophisticated sort of authorization mechanism and another layer of security on top of your backend using a combination of policies. So we use choose, we used validate jot, we use set variable in this case. And let me show you one. In fact, actually, I'm going to omit this example because we're sort of pretty tight on time. So let me go back to the slides and continue on. So over here, incidentally, by the way, we launched the service as a public preview at TechEd almost exactly a year ago. It was also May 12th, I think, back in Houston. And this is sort of basically some of the milestones we went through this year. And you can see that we sort of been very busy, and there was a major milestone every 3 months, right? And so now we're sort of in GA since September. We have premium in GA, so a bunch of work has been done. We are in 15 regions. We started just in a handful. Now we're in 15 regions all over the world, right? And we plan to be in more. But these are all the core Azure regions. These are some sort of vanity metrics. We have about 3,000 customers and billion calls a month and all the other interesting stats. So the service is getting used, getting traction. So we are very, very happy with that. And then, of course, we did a lot of work on the service itself, right? So service today is a lot more powerful and flexible than it used to be. And obviously, there's a lot more work for us to do. But we are essentially very determined to sort of, based on your guys' feedback and use cases, make it even better and more useful. So that was that. And before sort of, let me give you a little bit of a preview of what comes next, right? Let me caveat that first is that, so we sort of practice this lean product development. You probably heard of it. It's sort of pretty interesting concept in how to go about building products. And essentially, the idea is that you iterate and experiment, and you basically stay very focused on getting traction and adoption. And so essentially, we don't really plan that far ahead. We do know what we're doing now and what we're going to do probably next month or two. But beyond that, we kind of reprioritize continuously. We'll listen to feedback and adjust our plans. Some of the things that sort of I'm comfortable sharing with you because we're working on them actively right now include service configuration via Git. Git, I'm sorry. So this is actually a very interesting feature that allows you to manage configurations in various tenants using Git, right? So using Git workflow, using existing tools that you have and existing DevOps workflows that you're used to. We hear that a lot of customers want to do deeper customizations of developer portal. So we certainly working on that and making that a lot more tractable and allowing deeper customizations without too much extra work on your behalf. We have this interesting work going on where we're integrating with other Azure services, specifically Event Hub, where we would enable you using policy to shell out sort of information collected from the request context into an Event Hub that you procure. And then, of course, immediately from that, you can sort of read from that Event Hub either using custom code or attach things like Stream Analytics and then BI, Power BI tools to actually do some extra analysis, some extra analytics, some extra monitoring that you want to do. Run custom code. So you already saw some code running in the proxy expressions. That sort of was our first step. Next step would be to allow a lot more sort of interesting scenarios where there will be a lot more custom code that you can build, essentially where you can upload NuGet packages essentially to proxy with a bunch of dependencies and execute them as policies within the pipeline, right? So that basically will open all sorts of interesting scenarios related to integration with systems and fan out and things like that. And of course, we're working on some things that are basically such as management commandlets, SDKs, etc. So now on to my last demo that I want to show you. This is basically DevOps via Git, right? So this is sneak peek. This is first time we're showing this, so I hope you guys like it, and I hope it will work. So let me reload the portal. Now I need to go back and log in again. This is a special instance. Obviously, it's not publicly available, so I have to have a little magic trick here to get in. So here I am, right, and I have my Echo API, so it's standard API. Oh, I'm sorry. Thank you. So here we go. Standard API out of the box, right? So what I'm going to do is I'm going to make a change to it right here, right? I'm going to say echo demo at Ignite or something like that. And I say coming soon here. Save it. So standard operation that you can sort of do today. But here's the interesting part. So here I'm going to start command line. And I'm going to essentially clone. So what happens here is we have our system database, right, with configuration information. We also host a Git endpoint and a local repository in the cloud associated with the service. So you can actually sync up configuration from the service to Git, clone or pull from it, make changes, push them back, and apply them, right? So the operations of saving to Git repository in the cloud and reading from it are controlled through our API. And then you can work with Git as a Git endpoint using your workflow, and you can pull from Git, put into your own remote or local repo, and therefore keep versioned configurations. And then if you want to move things around, like take configuration from one tenant and load into another, it's a simple pull from one and push into another, right? So a very simple workflow, essentially two-step, right? You save configuration and then you pull it, then you push configuration and you apply it, right? So there's no automatic. So we don't roll these things, updates automatically yet. So here's what I'm going to do is I'm going to first save. Let me just start this little app. So this is basically an HTTP client, and I have pre-configured some operations. So this is a save operation, very simple post operation that will now talk to this tenant that I just showed you and persist the configuration that I just made, this change that I just made, that snapshot of that configuration into Git. And it supposedly already did so. So normally you would go and check the status link for completion, right? But we'll just trust that it did it. And so at this point, let me go and do here. I'm going to do clone of that into a directory called Git demo. Hold on, let me just make sure I'm in the right place. So I'm going to go into desktop, right? So it's easy to find, and then I'm going to do the cloning. All right, so hopefully it's done. So now, what we should be able to see, if everything worked, that there's git demo repo on my local, so I cloned. We don't have all the information yet. Again, it's work in progress. Imagine that here you will see everything, including your developer portal configuration as well. So here, we have APIs, and this is my Echo API, right? And you can see that this is the change that I made in front of you here. And then we externalized content here, right? So coming soon, essentially, this is the way we store it, but basically the high point here is that the configuration is down in those two files, and description is externalized. So let's go and change them both. So here we're going to say demo at Ignite 2015. Just change that one field. And then let me take the description and edit that, saying, right after this session. Okay? Save that too. So at this point, let me go back and just do standard Git stuff, right? I'm going to say git add all, right? I'm sorry, let me just do git demo, repeat, done. And then I'll do git commit. And I need to add a message, small changes, right? So committed to files, and now I need to do git push, right? And that way I'm pushing back into the repo associated with my service. So now my changes that I made here locally are in the cloud, in the tenant repo. And so all if I'm happy with that, at this point, I'm going to go and deploy that configuration, right? So I'm going to go and call a different, API on the service. Very simple, done, right? And at this point, if we go into the service itself, did I close it? Let me reopen that service, this git demo service. Okay, here we go. You can see that changes have been applied, right? There's 2015, and if you go to settings, you'll see also that description has been changed, right? So essentially, I'm changing. This is a very simple example, obviously, and as I said, it's work in progress. But what this shows essentially is that you can work with configuration of the API management system as just a Git repo, right? And right now, the application of those changes is sort of a process, through API, and we potentially will have an option for you to basically say apply those automatically. So if you make a change in the portal, we'll persist in the repo, and then, of course, if you update the repo, we'll apply the changes automatically. So that will be also an option. So that's a pretty cool feature. That is hopefully we're going to be done, pretty shortly, and you'll be able to take advantage of and now have basically something that you've been asking for a while now, ability to seamlessly and easily move configuration between different environments, right? Different API management environments. So let's go back to the slides and wrap this up. So for those of you who are, haven't tried the service yet, this is some of the information to help you get started. So you can actually get try API management at this particular URL. It's a very simple process. If you're already in Azure, you just do new and start from there. If you haven't asked a question, if you want to do a custom demo for you guys, if you want to have a discussion, here is an email address to send it to. There are some useful resources there. And with that, I conclude. Thank you very much. I appreciate your attention.